Our next speaker is from DAMEN Shipyards. The use of additive manufacturing in shipbuilding, optimizing ship shape and production. He is the research engineer at DAMEN Shipyards, focusing on optimizing ship production in multiple ways such as process improvement, manufacturing simulation, advanced robotics, and additive manufacturing. Please welcome Timo Kreule. Did I do good?
Yeah, more or less, thank you. Hola, my name is Timo Kreule. It's actually Timo Kreule. I work in DAMEN Shipyards group, and I guess a lot of you don't know what this company is, so I'll give a short introduction. So we are a shipbuilding company based in the Netherlands, but currently acting globally. We have quite a diverse portfolio of what we build. So we build super yachts. I think the best quality super yachts are seen as the Dutch ones. You can see quite a lot of them if you just walk into the port here. We build tugboats, high-speed transfer vessels, naval vessels. We're starting to build cruise ships. And this is only a few bit of them. I can stand here for an hour and talk about other ships we build, but we will not do this. So these vessels are all quite different in what they do, but there's one thing that they all have in common. On the inside, they basically all look like this. It's just flat panels, straight stiffeners, not too special. And it's not because this is the way all the stresses in such a structure work. It's because, well, flat panels are cheap, but it's also because all the people who design them, we look like these people, and we're also trained by people who look like this. Not saying that we are bad designers, of course, but the shipbuilding, compared to some other industries, I can say that this is a fairly consecutive business. It doesn't change that fast compared to automotive, for example. But, well, that's where I come in. I work in the research and development department of our shipyard. We have a lot of different focuses, hydromechanics, structures, and I focus in production. And if you really want to establish some things, you have to get away from the conservative people, we think. So that's why we have a separate office in this shed. This is an old shipyard in Rotterdam, quite a renowned yard, the RDM. It went bankrupt in the 90s and was then taken over by the Port of Rotterdam in their quest to become the smartest port in the world. So there are a lot of innovative companies, startups, new technologies, and we are also there. And one of the companies that we met there was this. This is RAMLab, short for Rotterdam Additive Manufacturing Lab. And they are a field lab in metal additive manufacturing. They want to use additive manufacturing for the marine and offshore sector. And when they started, they had these two nice little robots to do some research with. So we joined their network about 3 years ago, and in 3 years they grew from this, where you still see the two little robots on the right there, in quite a short time into this. A bit more serious situation, a bit more larger equipment, and a lot more knowledge mainly. And with them, we started to figure out what does it take to, well, in their case, usually you go out with a bang, but we want to come in with a bang. In the world of additive manufacturing, what does it take to blow the sector away, to really show what we can do? So with 5 different companies, we formed a team to make a world first. And so we took about 7 months, 7 kilometers of welding wire, of course one mandatory banana for scale. And after these 7 months, we ended up with this. So this is the world's first 3D printed propeller that is class approved. It is certified, so we can use it on board. This was about 2 years ago, and this not only gave us this propeller, it not only gave us a lot of attention, but also a page in the Guinness Book of World Records of this year, actually being the very first 3D printed ship component. And it not only gave us this, but also the thing itself, of course. What you can see is this is just a basic normal ship propeller. Is the same product that you make in a different way. And me being a researcher is well, it's really interesting, and we can use it, but it's of course not really the end goal, because what you want, you have this nice little technology, this nice technology, and you want to use it its advantages to make shifts better, to make projects better, to make your production better, cheaper, faster, to maybe even make your shifts better. So I started to conduct a new topic. I don't have all this knowledge myself, so I asked a lot of companies from other sectors, designers, universities, 3D printers, and we came up with with the first step. This is a patrol vessel. It's one of the key factors that we have is the Damen X-bow with the vertical bow. It has a lot of advantages. You can talk about this for an hour, but I won't. It basically looked like this. And the basic thing is that the bow is vertical, and on the other side it goes down in the front. And then you have a lot less vertical accelerations, a lot more comfort. And the thing we're interested in is this part right here. This is where the keel bar and the bow meet. And this is quite a sharp angle, and it needs to be smooth so that you don't have some local pressure drops. And basically, currently, how we do this is we take a block of 110 kilograms of steel, and we mill it down to this shape, and then it's still 60 kilograms, and we throw away like 50 kilograms in just scrap. And it works. Yeah, we can say it works, but there are some disadvantages. So this thing is really heavy. We cannot carry it by hand. We need to preheat the whole thing before we weld it into the ship. And it's not that we need the whole massive thing, we just need the shell. So now with the new technology, we can make any shape. So we can now make it hollow, just with a shell thickness of 6 millimeters. It only weighs like 5 kilograms, and you don't have any scrap anymore, apart from some grinding. So we basically save around 95% of the material we use. So we tried this out, and the thing looks like this. Still attached to the plate it was manufactured on. We just made this, and will be installed probably next year as the very first 3D printed ship components that is a constructive part of the hull. But yeah, this is still nice, and this is of course not the end goal for us. So we have more coming. We learned a lot from the propeller and from this thing, of course. We're doing a lot of research with universities from Delft and Rotterdam. And so we made a few lists of things that we want the technology to be able to do. We're not going to print a lot of parts that look the same, because then current technologies are probably cheaper and maybe faster. We're really in this to investigate what the technology can do. Can we make production faster? Can we make complex shape? And can we make our shifts better? First we start with some production. We are starting now to investigate what polymer printing can do. Together with the group of University of Rotterdam, we're finding out if polymers can work in a marine environment, if it doesn't shrink, if it doesn't fade. If any of you, maybe Victor, has enough knowledge that we can use for this, I'm more than interested, I can say. But what we see in a yacht like this or a ferry like this, there are a lot of round parts currently shaped out of aluminum that are quite difficult to form. They have to shape aluminum sheets around 3 axes. Quite expensive, quite costly, and takes a lot of time. Well, if we use a decent polymer, we can maybe print the parts. So we just make the straight parts of a ship out of aluminum or steel or whatever, and the interesting parts, the curvatures and the parts that don't really have to carry any load, we make them out of polymer to make your production faster and probably cheaper and easier for your workforce. Second thing is, of course, the really interesting part of the just as well interesting part for me as a researcher. Ship, of course, has a lot of parts underwater disturbing the water flow, giving vibrations, cavitations. And these are all things to consider when you want your ship to sail at higher speeds. At higher speeds, you get a lot of cavitation, pressure drops, which it's almost like you hit the hull with a hammer. That's the forces that you can exert on the hull. Your paint falls off. And with optimized shapes like this, we can either prevent this, improve your flow to the propeller to reduce vibrations, reduce cavitation, maybe even reduce your fuel consumption. And that's really why we're in this sector. We don't want to print some things just because we can print some things, but we want to either make our production better or make our ships better. We see the rudder that can be twisted to maybe make your flow even better, to have less of this disturbance. A propeller, it's a bit more complicated with some wing taps to also reduce cavitations to really improve the flow. And I think if we work this out, this will be started from, from now we're starting to design the parts. I think, and then we can really be proud again to offer the best solution, and we're not here to be the first. So the propeller was the first, but we're here to be the best shipbuilders that you can find today, and probably even better ones tomorrow. So that's our mission. If you have more questions, I will be happy to answer them after the session. Thank you.